Hi Nate. What I'm going to show you over the next couple of minutes are different screenshots of how I went through the process of the power analysis. I spoke this afternoon with Dr. Moore, and she shared with me a software package that is free to download, which is really helpful and really clear to follow when you're calculating power analysis, and I think this would be helpful for you. So what you want to do, it's called G-Power, and I just put in G-Power statistical software in the browser line here, and then you'll see that there's lots of different options. Don't be swayed by any of these other ones. What you want to download is University of Dusseldorf, and you'll bring up this page here and just scroll down, and you'll see you can download the manual, but where you'll really want to go down to is down here to download, and you'll just simply click on this. And I'm going to bring up, I actually downloaded this earlier, so I'm just going to scroll down and show you. So you'll get a zip file, and then what you're going to do is you're going to open your zip file. Don't worry, just get rid of, I just close that typically, and I double click there, and what you're going to want to click on is a Setup X, and it'll install it on your computer. If you open G-Power from one of the other sites, it is possible that you're going to get some additional software that you don't want. So do remember to go to the Dusseldorf option. So I'm going to just minimize this here because I already have this downloaded. So what you're going to do is you're going to go, it'll download, mine downloaded straight onto my desktop. So I'm just going to click on this. I'll bring this up here so you can see my screen. Let's see. Alright, so the statistical test that we're going to look for is going to be, we're going to look at the difference between two independent means, in other words, two different groups. And look down here, that's correct. And I'm going to look at it as being two-tailed. In other words, the outcome could go one of two ways. When we know for certain, or we're fairly certain that we know the exact direction of an outcome, in other words, that the experimental group are always going to do better or always do worse, we'll choose a one-tail test. But when we're not quite sure, the safer bet is to go with the two. We've talked before about the 5%. We're going to put in here for 80. Now, I'm going to come over here to determine. And what I'll do for the mean, so I'm going to plug in some numbers. The file that you said sent this study here, I know that you said you worked from these numbers. I'm going to scoot on down to table 7, I believe. And what we looked at when I worked with Dr. Moore this afternoon, we looked at the post-test range reflection in the experimental group versus the control group. So these are the numbers that we're going to plug into the G-Power. So if I took for the mean of the group 1, which is our experimental group, oops, mistyped there, 55.6, and then we look at the mean of the second group, and then we add in standard deviations for each, and then I'm going to calculate an effect size. That's pretty good effect size if we think of Cohen's D's. And then transfer to the main window. So this number here is going to be transferred over to the effect size here. So you'll see this change. And then at this point, what we want to do, let me bring the screen up a little bit more. I don't think you can quite see it in my screen. Let me see if it'll come down in size. Nope. Right at the bottom, I'm going to extend this down here. It says the word calculate. So we'll pop that in there. And what that does is it brings up how many participants you need in each group. So we're looking at 18 in each group for a total of 36. So this is assuming that you're going to see this difference between the two groups, that you really clinically believe that there could be up to 10 degrees of difference between the two groups at the final measurement point. If you were thinking to be a little bit more conservative and thought perhaps maybe it's only going to be about 5 degrees, what we would do is we recalculate this, and then I'd calculate again, and you can see here how by being a little bit more conservative, so rather than 10 degrees of difference, 5 degrees of difference we're thinking, you can see how that dramatically affects the number that are going to actually be in the study. So you're looking at going from 36 up to 104. One other thing I just want to show you here, let me go plug this correct number back in a moment and go back to the original calculation. So that was it. One other thing to show you that's kind of nice to look at here, we're going to draw the plot. And what we see here, so right now we were looking at about 80%, and we can see that that's about our 36 number of populations. If you wanted to increase the power up to 0.9 or 90%, you can see here that you're going to have to up your numbers to about 47 or so, 48 in the study. So again, just gives you a sense of when you start changing some of the parameters, how that affects your N or your recruitment number. Let me just close out of here. So again, right now we're looking at possibly there being in the region of about 36. I know you said you had access to more data points than this, and this would allow you make sure that you are choosing the cleanest points as you think about the data to include in your study. So we can talk a little bit more about this, but hopefully this description of how to do the power analysis and providing you with the tools will complete that portion of your methods section for your current assignment. If you have any questions after this, please don't hesitate to let me know, but hopefully this has been helpful for you to kind of see the process of working through power analysis.